go ahead and try to solve this here up on my Smart Notebook, maybe. Okay, so I'm going to start with the elimination method. With the elimination method, does anybody remember how you eliminate a variable? What do you mean by find its reciprocal? Okay, so I need to come up with a multiple that I can multiply the second equation by that would make it the same as 4, but do I want it to be a positive 4? A negative 4. So I need it to be a negative of the same coefficient. So, for example, you said let's get rid of the y's. If I want to get rid of the y's, then I need this y to be a negative 4 so that when I add these two equations straight down, they will cancel out. Okay, that's the elimination method. What if I wanted to get rid of the y's? What would I need to multiply this bottom equation by? Negative 2. So one option would be to multiply the bottom equation by negative 2. When you get into Algebra 2 and you're doing lots of equations, your teachers are probably going to teach you to number your equations so that you can easily follow your work and find those equations as you're going through. So I'm going to multiply equation number 2 by negative 2. Remember that when you do that, you have to multiply every single term. You can't pick and choose what you're going to multiply. To keep an equation balanced, whatever you do to one side, you have to do to every term on both sides. What if I wanted to get rid of the x's? What would I need to multiply the bottom equation by? You would have to multiply both. So what would I need to multiply the bottom one by? Negative 2. What would I need to multiply the top one by? Positive 5, so that they both turn into 10, where one's positive and one's negative. So elimination method, you sometimes have to multiply both equations by a number. It just depends. But your goal is to get the same coefficient in front of the variable where one is positive and one is negative, so that ultimately they eliminate when you add them straight down. So when we multiply this equation number 2, I'll come over here. By negative 2, we're going to get negative 10x minus 4y equals negative 216. Is that correct? Okay. Then I'm going to bring equation number 1 back down underneath so that I have 2x plus 4y equals 72. And then I'm going to add straight down. So when I add these together, negative 10 plus 2 is negative 8x. Negative 4 plus 4 cancels out. And that equals, what's negative 216 plus 72? Negative 144. Good. And then I'm going to divide by negative 8. And so x is going to equal positive what? Okay, 8 goes into 14 once. With 6 left over, 8 goes into 64 8 times. So x is equal to 18. Questions so far there? Okay. Then I'm going to take that and do what with that to find y? Plug it in. Does it matter where I plug it in? No, I can plug it back into the original number 1, number 2, or even the ones I've changed. Doesn't matter. I'm going to go back over here into equation number 1. I have 2 times x, which is 18, plus 4y equals 72. 2 times 18 is 36, plus 4y equals 72. Subtract 36. And I have that 4y is equal to 36. And then divide by 4. And y is equal to 9. And when you're solving a system, typically you write your answer as coordinates, as an ordered pair. So this would be x 18, comma y 9. 18, comma 9. So remember that with the system, that's the point where the equations of those two lines would do what? Intersect. It is the point that works in both equations. So when they cross, that's the point where they would cross. This would be our solution, 18, comma 9. Questions on elimination method? Okay, let's talk substitution method. I'm going to go ahead and do substitution method as well. So I'll show you that way just so that you can remember both. Help me out here copying these down. This was 2x plus 4y equals 72. And then 5x equals, I'm sorry, what? Positive 108? Okay. All right, so with substitution method, what do we want to do? Substitute what? Say it again. A variable. Does it matter which variable? No. So you need to pick one of your equations, and you need to solve one of those equations for one of your variables. And by solve, that means get the variable on one side by itself. So I'm going to choose equation number 1 because every number in equation number 1 is even, which means they're all divisible by 2, which means I probably won't end up with fractions when I'm trying to divide and solve. So think strategically about what equations might be easier to work with. So 2x plus 4y equals 72. And I'm going to solve for which variable? X, because if I try to solve for y and I have to divide everything through by 4, I'm going to end up with a fraction in front of the x, right? So I think it'll be easier to solve for x. So first thing I'm going to do is subtract that 4y to the other side, because I want to get the x by itself. So 2x is equal to negative 4y plus 72. And then I'm going to do what? Divide by 2. And remember that every single term gets divided by 2. So now x is equal to negative 2y plus 36. Once you have what x is equal to, then just like we talked about when we were writing proofs, we can now substitute all of this in for x where? Okay, which equation? Number 2. You don't want to plug it back into the one you just started with, or everything's just going to cancel each other out. You have to plug it back into the other equation. So this is going to get plugged into x over here into equation number 2. So now I have equation number 2. I have 5 times, plugging all of this in, negative 2y plus 36. Sorry, my board is not writing very good right here. So negative 2y plus 36 plus, so 5 times x plus 2y equals 108. So just substituting all of that in for x. Then what do we need to do? Distribute. So we're going to distribute the 5. That gives me negative 10y plus, what's 5 times 36? 180 plus 2y equals 108. Negative 10y plus 2y gives me negative 8y plus 180 equals 108. Then we'll subtract that 180 to the other side. Thank you. And we get negative 8y equals negative 72. Divide by negative 8. And we get what? Positive 9, which is the same thing we got when we did elimination method for y, right? And now it's the same process as elimination. Once you figure out y, you substitute it back in somewhere. That's exactly what I would do, Remy. I could plug it into 1 or 2 or even here, but it's probably easiest to plug it in where you have x equals, because that's your goal now, is to solve for x. So I would usually plug it back in over here. So we have x equals, I'll slide this back up, negative 2 times 9 plus 36, which gives us negative 18 plus 36, which is equal to, careful, it's a negative 18 plus 36, so it's 18. And then again, you can write that as an ordered pair, 18 comma 9. It's the same 2 equations, so you should have ended up with the same point of intersection. Questions? How many of you are having a lot of fun working with algebra again? It's like, I miss algebra. But then you'll get to algebra 2, and you'll be like, man, I miss the good old days in geometry. And you'll say no now. Come see me next year. I promise you. It'll get hard, and you'll come back saying, man, I miss geometry. Yes? Okay, here's some algebra 2 kids right up here. Have already had algebra 2. Listen to them. I'm telling you. Algebra's fun, but it gets harder. And sometimes it gets a little harder, and then you miss the good old days of geometry. And then one day you'll find yourself in Cal 2, like my freshman in college, and they're saying, if only I was back in geometry, because it's really hard. But there you go. Sorry. Okay, what did you do, Bryson? So it's the exact same thing. You did elimination method. The only reason I don't teach it that way, Bryson, and some teachers do teach it that way. So here's what Bryson's saying he did. He multiplied the bottom equation by positive 2 so that he had this. And then he subtracted. And it's fine to do that, but what I usually, oh, thank you, sorry. That's not what Bryson said. He said 216. I wrote the wrong thing. Okay, but the one thing I've found over the years of teaching is that some students will do 2 minus 10, and then they'll forget to subtract the rest and they'll add. And so you have to remember to distribute that negative throughout and to subtract each term. And so because I see students who make that error, I just always teach get the same number, one positive, one negative. And then you already have it distributed throughout so that you don't have to worry about it. But this is perfect, works every time. Any other questions? No, not at all. All right, so here's the thing. If you know right now you do not feel confident that you could do this on the test by yourself, you need some practice. Come see me. I can give you some places of problems you can practice, and I can help you one-on-one if you need to. But we're going to move on to Chapter 3, where you will have to use substitution at times, okay? Not all the time, but sometimes. Okay, so we are going to look at what you did last class period, which was 2 lines cut by a transversal. But today, we are going to start with if the lines are parallel. And I'm going to make a big deal about it because what we're learning today is only true if the lines are parallel. This is not true if the lines are not parallel. And you cannot assume they're parallel. They have to give you those arrows or tell you that they're parallel. So if the lines are parallel, then we're going to look at what happens today. We're going to start with one postulate, and then I'm going to let you develop the rest of them so that you'll see how easy it is and why they work. So the very first postulate that we're going to learn today is the corresponding angles postulate. Yes, sir. So it's technically a postulate, but you can prove it true, so they'll call it a theorem here. We're going to call it a postulate because we're going to accept this one as true. We're not going to prove this one, but we're going to use the corresponding angles postulate to prove the other ones today. So we're going to call the rest of them theorems. So just remember that a theorem is something you can prove true, and there is a way to prove the corresponding angles postulate by using the other theorems, then it would become a theorem. Okay, so I can cross that out if you want to on your notes, you can too, and we're going to call this the postulate. We're going to accept this first one as true, and then we're going to prove the rest. So this postulate says if two, and I'm making a big deal about it, parallel lines, this is only true today if the lines are parallel. If 2 parallel lines are cut by a transversal, then the corresponding angles will be congruent. The corresponding angles will be congruent. So today we're going to look at some angles that are going to be congruent and some angles that are going to end up being supplementary. But again, these are only going to be true if the lines are parallel. So this says that corresponding angles will be congruent if the lines are parallel. Notice the little parallel marks. So we know the lines are parallel. So our corresponding angles, one more time, are things like 1 and 3, 2 and 4, 5 and 7, or 6 and 8. I think of them as in the same position. So if you look at the groups of 4, the 1 and 3 are in the same position, the 2 and 4 are in the same position, so forth. Okay? So here's what I want you to tell me. Let's say, for example, that I know angle 1 is 100 degrees. What is angle 3 going to be? 100 degrees. What kind of angles are 1 and 6? Vertical. What do we know about vertical angles? They're congruent. So I'm going to come over here on this little list on the board, and you may want to write this in your notes. If the lines are parallel, we just learned that corresponding angles are congruent. And that will always be true if the lines are parallel. But we also know from other lessons that have nothing to do with the lines being parallel. So these have nothing to do with the lines being parallel. But we also know that vertical angles are congruent as well. And that is by what theorem? Okay, the vertical angle theorem. But today we're saying that corresponding angles are congruent by the corresponding angles postulate. Okay? So if I know that vertical angles are congruent, what's the measure of angle 6? 100. And if I know corresponding angles are congruent, what's the measure of angle 8? 100 degrees. So now I want you to look at 3 and 6. What kind of angles are 3 and 6? Careful. Alternate interior. So going back to what we learned last class period, everybody agreed that 3 and 6 are alternate interior? So what do you notice about alternate interior angles if the lines are parallel? They're also congruent. So on this list, we're also going to have alternate interior angles will be congruent if the lines are parallel. And in a minute, we'll look at our notes, and it's called the alternate interior angle theorem, because we could prove it true by using these corresponding angles like I'm doing right now. Okay, what do you notice about angles 1 and 8? What kind of angles are 1 and 8? And what are they on the picture? Okay, so they're also congruent. So we can also say the alternate exterior angles are going to be congruent. And in a minute in your notes, you'll see that that's called the alternate exterior angle theorem. Everybody get it so far? Okay, so now let's go back to what do we know about angles 5 and 6? What kind of angles are those? Okay, they're a linear pair. And what do we know about linear pairs? They're supplementary. So under the supplementary column, nothing to do with lines being parallel. So I'm going to draw a little line because it has nothing to do with the lines being parallel. We also know that linear pairs are supplementary, right? And again, what theorem tells me that? The linear pair theorem. The more we write this down and say it, the more those theorems are going to stick in your mind. So we know that linear pairs are supplementary by the linear pair theorem. So we know 5 and 6 have to be supplementary. So what does the measure of angle 5 have to be? 80 degrees. And if 5 is 80, what does angle 2 have to be? 80 because they are vertical. Okay? And if 2 is 80, what does 4 have to be? 80, and why? Because they're corresponding. And if 4 is 80, what does 7 have to be? 80 because they are vertical. So now look at 2 and 3. Going back to the last class period, what kinds of angles were 2 and 3? Careful, 2 and 3. 2 and 3 are not a linear pair. They are not adjacent. Same side interior. What do you notice about the sum of 100 and 180, or 180? Okay. They're supplementary. So same side interior angles will always be supplementary if the lines are parallel. Same side interior angles will always be supplementary if the lines are parallel. And then the last angle pair that we talked about last class period, look at angles 1 and 4. What kind of angles are 1 and 4? And what do you notice about the sum of their measures? Okay, they are also supplementary, and that will always be true if the lines are parallel. So same side exterior angles. So basically today there are 5 new postulates or theorems in your notes. We started with the first postulate, and the only reason we called it a postulate was because we used it to then develop the rest of them. The rest of these are going to be theorems. Because we can prove them like we just did by looking at a specific angle measure using the fact that the corresponding angles are congruent. We can get that the rest of these are congruent and that these are supplementary. We also have these down here that are congruent and supplementary because of the previous lessons that we've learned. So now we have several angle pairs that are going to be congruent and several that are going to be supplementary. And the rest of 3.2 is going to be looking at examples and trying to decide how to solve for the angle measures using these theorems or postulates, okay? If you look in your notes, here are the, I'll come back to that in just a second. Here are the rest of them. It's so hard to read in your notes because it's so tiny. So just know that these are cut out of the textbook. If you look in the textbook at section 3.2, the charts are on there nice and pretty and colorful and easy to read. So if you're having a hard time reading them in your notes, just go back to the book. But here is your alternate interior angle theorem that says alternate interior angles are congruent. The alternate exterior angle theorem that says the exterior angles are congruent. The same side interior angle theorem that says they are supplementary. And then this book always skips the same side exterior. So you may want to add right here the same side exterior angle theorem. And it's going to say that if 2 lines are parallel, then the same side exterior angles are supplementary. So it's going to say the exact same thing as this one. It's just that we're exterior angles now. Is that okay? Any questions up till now? Okay, I'm going to go back because some of these slides I skipped are super important for the test. So if you look here, if a transversal is perpendicular to 2 parallel lines, so parallel, I have 2 parallel lines and I have a transversal that's perpendicular to those 2 parallel lines. When it's perpendicular, it's going to form what kind of angles? Right angles. And how many right angles? Okay, 4 at each intersection, right? So all 8 of these angles are going to be right angles. So it makes sense that all 8 angles are going to be 90 degrees or congruent. Is everybody okay with that? So how many different angle measures are formed when 2 parallel lines are cut by a transversal perpendicularly? Listen to the question again. How many different angle measures are formed? So there's only one angle measure, right? They're all the same. So one angle measure. What if we look back at our example we just did? If you have 2 parallel lines cut by just a transversal, how many different angle measures are there in the picture? 2. They're either going to be, in this case, 100 or 80. Depends on the picture, but every time there'll only be 2 different angle measures. Does that make sense? Okay. All right, and then we already talked about that because Kenyon brought that up early. Okay. So now we're just going to look at some examples. You can make this hard or you can make this easy. Just depends on how your brain works and what you notice first. My advice when you work these problems is to first of all make sure that you have 2 parallel lines, because none of what we learned today is true unless the lines are parallel. So do not assume that they're parallel. Once you know they're parallel, I would look for an angle measure in my picture. Once you find an angle measure, if there's an actual value, you should be able to find every other angle measure in the picture. And that will be quicker than worrying about these expressions. So for example, if this is 70, what's this angle measure? And if this is 70, what is this angle over here? 110. And if this is 110, what is 4x plus 22 going to be the same as? 110. And if this is 110, what is this angle going to be? Careful. What kind of angles are these? Alternate interior. And what do we know about alternate interior angles? No, no, no. Stop before you answer. Make sure you know what you're saying. Alternate interior are congruent. Okay, so what should this angle be? 110. And if this is 110, what should this angle be? 110 because they are vertical. Okay, if this is 110, what is this angle? 70 because these two angles are what kind of angles? Same side interior, very good. And if this one's 70, what is this one? Because they are vertical. And they're going to ask you constantly to back up the why. So that's why I keep asking you, why? Why? Is it corresponding? Is it same side? Is it linear pair? Is it vertical? And make sure you're giving the whole name. Vertical angle theorem, linear pair theorem. Okay, so now these should be quick and easy to answer, right? What is the measure of angle ECF? 70 degrees. Now on the homework they may ask you, name the theorem that you use to get that. You may all have a different theorem that you use. It may depend on what method you thought about it. You might have started with this was 70 and got that this was 70 right off the bat because these kind of angles are what? Corresponding. So you would put corresponding angles postulate. But you may have a friend who said first, I'm going to say if this one's 70, then this one's 110. What kind of angles are these? So they may say same side interior angle theorem, and then they used linear pair theorem to get this was 70. So they would have two answers down on their paper because they thought about it differently than you. But both of those answers would be correct. So you're going to have to explain your thought process. Does that make sense? Okay, so checking your answers in the back, your reasoning may not be the same as the back of the books. Okay, but did this say to explain your reasoning? No. So if this were a homework question, 70 is all you would have to put. Don't forget your degree symbol. But I do think that some of the questions on the homework tell you to name the theorem or postulate that you use. Okay, what's DCE? Okay, did it say find x? No, it just said what's the measure of DCE. So what's DCE? 110. So notice you could make it harder and you could solve for x and then plug it in. But all it asked for was the measure of the angle. It never once said find x. So we don't even need to use those expressions. Does that make sense? Okay. What would we have done if we would have looked at the two expressions? What do we know about these two expressions? We could have set them equal to each other because they are what kind of angles? Corresponding. And corresponding angles are congruent. So we could have set them equal and solved for x and then plugged it in and found 110. But again, that would take a lot of extra work that we didn't need to do. Okay. Any questions? All right, let's keep going here through 3-2. All right, so look at these. They want us to find QRS. Be careful. QRS. Where is QRS? It's an angle. Okay. Where is QRS though? Where is it? Give me a description. QRS is adjacent to what angle is QRS? Angle X. Okay, so QRS is talking about this angle right here, right? So that's not X. But what do we know about these two angles? They're corresponding, so they are congruent. So what is X? 118. What do we know about X and QRS? Okay, they're supplementary. Why? Because they're a linear pair. So we could say that the measure of angle QRS is equal to 180 minus 118, which is 62 degrees. If I did it that way, I used two theorems. I'd have to list them both if it said explain. But there's a quicker way to just use one theorem. Very good. These two are same side interior, and we know that they are supplementary. I think about it as SSS, same side supplementary. Just be careful. Corresponding angles are on the same side, but they're not called same side. They're called corresponding. And corresponding angles are congruent, but same side are supplementary. And then you have the linear pairs, which are also supplementary. Okay, so can I see your notes real quick? You have 3 more examples. I'm going to give you a few more minutes before I have you work it. I'm going to have you try them together in your pairs. I want to point out where these things are located. This is pointing to this angle right here. This is for this angle. This is for this angle. Everybody clear? Because I'm going to change the slide. Okay? And 75 is this angle. Those are pretty obvious, I think, but in case you didn't notice, I'm going to skip this one. Oops, maybe. And go to this one. This angle is talking about this one and this one. That one's a little harder to tell which angle they were referring to. So make sure you fix that in your notes, because I'm going to change the slide. And then the last example. Make sure you're clear. This 5x plus 4y is pointing to this angle. This 5x plus 5y is pointing to this angle. 60 is this one. 55 is this one. And now I want to give you a little bit of time, and I want you and your partners to try to work the last 3 examples. Not done, because we're going to work through it. But let's go back to the first one I had you try. Was that this one? Yes. Okay. So EDG, what did you get for EDG? Let's go with Lucas. 75 degrees, okay? There's lots of different ways you could think about it, but me personally, I would say EDG is an alternate exterior angle to 75, and so I know that alternate exterior angles are congruent. Is that okay? And if I had to list the reason, I would say alternate exterior angle theorem. Okay, moving on. If you have a question, stop me, because I'm going to go pretty quickly. Anybody have a question on that one? All right, lots of different ways you could have done it, but that's one way. BDG, let's go with Logan. What did you get for BDG? 105 degrees. Again, there's a lot of different ways you can think about it. Me personally, I would say once I know this is 75, then these two form a linear pair. So therefore, the linear pair theorem would say they're supplementary, and that gives me 105. Questions on this one? Okay. Again, I didn't have to use those expressions at all. Don't think that you always have to use the expressions. They just do that to make things a little harder for you. Okay, on this one, we will have to use our expressions. So first of all, tell me what kind of angles are these? Let's go with Zach. These 2 angles in the picture, what kind of angles are those, the expressions? Alternate interior, and we know that alternate interior angles are congruent, so you should have started by setting those equal to each other. Congruent means equal measure. From here, you're just going to solve for x, subtract 2x. 10 equals x minus 15, add 15. I don't know why my board's having trouble there. And I get x equals 25. Be careful of the directions. Some of your homework problems are just going to say solve for x. You're done at this point. Some of them are going to say go back and find an angle measure. So A, B, D is this angle. So we're going to plug that 25 back in. And Lorena, what did you get for angle ABD? 60 degrees. 2 times 25 is 50 plus 10 is 60 degrees. Don't forget to put your little M's when you're writing your final answers. Questions on this one? Yes, ma'am. So if it asked you to give your reasoning behind what you did, you would have set up those equations using the alternate interior angle theorem. And then you wouldn't have to go further than that. It's not going to ask you to write an entire proof. It's just simply going to say what theorem or postulate did you use to solve this. And you're picking from one of these 7 different theorems that we've learned on the board. Is that good? Okay. All right, moving on to the last example in 3-2. I want to warn you to be very, very careful. What was the first thing I wrote on the board today? Okay, if the lines are parallel. So again, you have to make sure that you're checking to see, are they telling you lines are parallel? Which lines are not marked parallel in this picture? P and Q. So you cannot look at P and Q and say, oh, these are corresponding, so they're equal. Because P and Q are not parallel. Therefore, corresponding angles are not going to be congruent unless the lines are parallel. So you can't look at it that way. Instead, you have to look at your parallel lines like M and N. If these two are parallel and I use only transversal Q, what kind of angles is this angle and 60? Those are corresponding. So I can say that they are congruent. So I can write that 5x plus 5y equals 60. And again, on the homework, if it says, what theorem or postulate did you use? You would write corresponding angles postulate. That's how you set this equation up. Then you would move to the second equation. So now if we use this line L and this line N, because they are parallel to each other, but we use this transversal P. What kind of angles are this angle and this angle? Okay, they are alternate interior looking at transversal P and these two lines. And we know alternate interior are also congruent. So we can say 5x plus 4y equals 55. Questions on how we got those two equations? Okay, at this point, what are you going to have to do to solve this equation? Exactly. So now we're back to substitution or elimination. You can use Bryson's method here pretty easily to just subtract the two equations because both the x's have a 5. Or if you're afraid you'll forget to distribute that negative, you can multiply the bottom equation by -1. And then that would give you negative 5x minus 4y equals negative 55. This would be my equation 2 I started with, and then I'm going to write equation number 1 down underneath. 5x plus 5y equals 60. If you add straight down, what's going to happen to those x's? They're going to cancel. This is 5y, guys. Sorry, it's not writing good. What's negative 4y plus 5y? 1y or y. And negative 55 plus 60? 5. So y is equal to 5. And then we plug that back into one of our equations. I'll come up here to number 1. So I have 5x plus 5 times y, which is 5, equals 60. Gives me 5x plus 25 equals 60. Subtract 25. 5x is equal to 35. 35 divided by 5, and what is x? 7. Again, it did not say write this as an ordered pair. It did not say find the solution to the system. It just said find x and y. So you can just simply say x is 7, y is 5. You don't have to write it as an ordered pair. We're not in algebra solving systems. We are using algebra in our geometry to find x and y. Questions? Okay, 3-3. Yes, sir. In the book, it talks about how it could be, I think, in the example in there, but they stretch really far sometimes in this book to make it applicable. So, yeah. I will tell you, there are some things in geometry you probably won't use unless you become a mathematician or a math ed major. And there are some things in geometry that you truly will use no matter what you do with your life because they are real life applicable. Calculating the square footage, or if you're going to paint a room, how much paint am I going to need? Things like that you really could use no matter what you do. My son Spencer, I refer to him all the time just because I'm learning as he goes through school things that he can say for sure I used in this class. And so he would tell you that you're going to use area and volume in your other classes. You're going to use perimeter in your other classes. You're going to use trig when we get to the basics of trig in here all the way up. He used it in Algebra 2. He's going to use it in pre-Cal, Cal 1. He's using it again in Cal 2. He sent me a picture the other day in his Cal 2 class where she said you need to know your surface and volume and formulas from geometry. And his teacher, his professor said, I know a lot of you probably have a limited geometry background. And I said, you tell her. Your geometry teacher was amazing and you learned all kinds of things. But of course, he's not going to say that. So, but for real, you're going to need a lot of this. As you go further in math, proofs, they kind of are some of those things you just have to suffer through to think logically unless you go on. Now, in college, I had to use proofs, but that's because I'm teaching math for a living. If you weren't teaching math for a living, probably not going to be as necessary. You know, unless you just love it, then you might do it for fun on the side, but highly doubtful. All right. 3-3, let's transition to the next section. 3-3 is going to go with everything we just learned and switch it. 3-3 is all about the converses. So we're going to take everything we just learned, which started with if lines are parallel, then this is all true, right? Okay, so now 3-3 is going to say, switch that, if, and then we're looking at whether or not the angles are congruent or supplementary. So if corresponding angles are congruent, alternate, I'm going to abbreviate, do not abbreviate, but you can do all kinds of amazing things in your notes, just not when you turn it into me. So alternate interior angles, if they're congruent, alternate exterior angles, if they're congruent, or if corresponding angles, excuse me, not corresponding, what am I writing? So sorry. Same side interior angles, or same side exterior angles. If these angles are congruent or these angles are supplementary, then what could we say? No. Okay. Remember, we're flipping. So if the lines are parallel, then these things are true. So if these things are true, then the lines are parallel. And 3-3 is basically all converses proving lines parallel. Okay, that's going to be our goal in 3-3. We want to prove the lines are parallel. They're not going to be marked parallel. So we're going to be looking for one of these theorems, and these are all going to be converses. So the theorem is going to be converse of the corresponding angles postulate. Converse of the alternate interior angles theorem. Converse of, so when will you use converses? No. If you're proving the lines are parallel. Not if they're parallel. If they're parallel, that's the original theorem. If you're proving the lines parallel, then you're going to use the converses. That's the only time you're going to use converses for this section is if you are proving the lines are parallel. If your conclusion is the lines are parallel. Okay, so I like to just kind of give you a big heads up. This is what we're doing. So here is the first picture in your notes. Notice it's called the converse of the corresponding angles postulate. It starts out if two coplanar lines. Does it ever say the lines are parallel? No, because you don't know they're parallel. They're not marked parallel. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So notice the switch. Here we have a picture. We notice that the corresponding angles are marked congruent, or they give us that the corresponding angles are congruent, and we can conclude the lines are parallel. Also notice that they don't put the word line in front of the lines when they're using them in the proofs. So they'll just put M as parallel to N. Okay, so converse of the corresponding angles postulate is used when you're trying to prove lines are parallel. When your conclusion is lines are parallel. Okay, I'm going to go pretty quickly through these because we just talked about what they are. Converse of the alternate interior angles theorem does not say the lines are parallel. It says if the alternate interior angles are congruent, then you can conclude the lines are parallel. Okay? Converse of alternate exterior. If the angles are marked congruent, then you can conclude the lines are parallel. Converse of the same side interior angles theorem. If the same side interior angles are supplementary, so notice that they're showing you that they add to equal 180, then the lines are parallel. And go ahead and add to your notes the one the book always skips. Converse of same, I give up, same side, I'm not even going to write it on the board, I'm going to write it over here. So if you're watching the video, I'm writing this on the board. Converse of same side exterior angles theorem. I'm going to tell you, I'm going to warn you, on the Chapter 3 test, knowing when to use converse and when not to use converse is going to cost you several points. So make sure you're careful. You are only using converses when your conclusion is that the lines are parallel. So when you are saying this line's parallel to this line, it's the converse. So in the picture, it would be something like this. And if they said measure of angle 1 plus measure of angle 7 is equal to 180, then the same side exterior angles would be supplementary, so the lines would have to be parallel. So that would imply R is parallel to S. Are we clear? Okay. Converses are used when you are proving lines parallel. I hope I've said that several times today that it's starting to stick in your head. Okay, so now we're going to work some proofs. On your homework, it is going to say show. And I'm going to tell you that when you see it say show, I want you to write a 2-column proof. The book may not set it up this way. I'm telling you, you have to. Okay, that's how I'm going to grade it, so make sure that you are. This is really super simple. It wants you to prove that L is parallel to M. And it kind of tells you exactly how to do it if you read it. But I'm going to ignore that for a second. Prove L is parallel to M. This is what you are given. So in your 2-column proof, statements, reasons, and everything that keeps fading, you know what it is. You can do it. Statements and reasons. First thing we're going to write down is whatever they give you in the problem. So angle 4 is congruent to angle 8. What's the reason? Given. Then you're going to look at 4 and 8 and you're going to ask yourself, what kind of angles are 4 and 8? Corresponding, and if corresponding angles are congruent, then the lines are parallel. So we can go right to statement number 2, L is parallel to M. And what is the reason that we're going to write down? Okay, converse of, because we're saying that lines are parallel. So anytime your statement is lines are parallel, your reason needs to be converse of, and then whatever angle pair you did. So this is corresponding, and it's the only one today that is a postulate. We just accept it as true today because we use it to prove everything else. And that's it. That's all you have to do. So not super long and hard, but setting it up as a proof. Questions here? Okay, we're going to look at a different one. So we want to prove that L is parallel to M again. Notice we've got a little bit more information here given to us. So we start with our two-column proof, statements, reasons. Number one, we're going to list all of our given up here. Measure of angle 3 equals 4x minus 80. Measure of angle 7 equals 3x. I don't know, I'm going to have to call tech and have a look at my smartboard because it's obviously a smartboard issue right in that area. And then we have that x is equal to 30. And this was given. Okay, then we're going to look and see what kind of angles are 3 and 7. Corresponding. So we need our corresponding angles to be what? Congruent, and we're going to have to show that they're congruent so that we can say the lines are parallel. So this one is going to take a little bit longer. So what would be the first thing we might need to do to start figuring out what their measures are? Substitution. So we're going to go to step number 2, and we're going to substitute in that 30. So measure of angle 3 is equal to 4 times 30, and that's minus 80. And at the same time, I'm going to substitute it into angle 7. So measure of angle 7 is equal to 3 times 50 minus 50. And what's the reason? Substitution. Oh, I'm sorry, it's 30, isn't it, not 50? My bad. This should be 3 times 30. Please fix that. X is 30. Substitution, property of equality. Okay, I'm going to go to the board over, I don't know where. Over here. Okay. So now we're going to look at what we have, and what do we want to do next for step number 3? Simplify. So measure of angle 3, what is 4 times 30? 120. We can go ahead and simplify it all at once. What's 120 minus 80? 40. So measure of angle 3 is equal to 40 degrees. Measure of angle 7, go ahead and simplify. What's 3 times 30? 90 minus 50? 40 degrees. What's the reason that we used? Simplify, or we could also say combine like terms. All right, from here, we have to show that they are congruent. We're not there yet. What can we use to show that 3 is equal to 7? Not yet, we'll use that next. What tells me that if this is 40 and this is 40, that these are equal to each other? Careful. Reflexive says something's equal to itself. Angle 3 equals angle 3. Symmetric takes something and flips it over. Okay. You guys need to study reflexive, symmetric, and transitive. Transitive takes something that is exactly the same on both sides of an equation, gets rid of it, and makes a third equation that the measure of angle 3 is equal to the measure of angle 7. That is the transitive property. That you need to work on. Transitive property of equality. Okay, now, Liam, what tells me that if 3 is equal to 7, that 3 is congruent to 7? Definition of congruence. So number 5 would be angle 3 is congruent to angle 7. This process is going to be pretty much the same every time, so the more you work on the homework, the easier it's going to be for you. We've said 3 is congruent to 7, so now if the corresponding angles are congruent, what can we say? Okay, and what 2 lines are parallel? L is parallel to M. And what's the reason? Converse of corresponding angles postulate. Converse of corresponding angles postulate. I'm telling you, you need to know how to do these proofs. The more you write it down, the more you're going to memorize it. But you will see these on the test. You will see these on your homework. Okay, I want to go over one more. Let's see what else is in your notes. I'm not going to go over all of those. Mrs. Ashley. Yes, sir. It's okay. Yes. Yeah, you want to talk? Sure. Yeah. Hold on just one second. Jordan. Okay. No. Okay, I want you to skip to, first of all, let's talk about this parallel postulate real quick. This is important for next class period through a point P not on line L. So on your paper right now, draw a line L. Draw point P not on line L. How many lines can you draw through point P that would be parallel to line L? Everybody agree? That's this postulate. It says through a point P not on line L, there is exactly one line parallel to L. So everybody agrees that there's only one line we could draw through here that would be parallel. Okay, next class period, we're going to be doing constructions, and we're going to construct parallel lines. Yay! Okay, I'm going to skip this one because it's identical to what we just did. I'm going to skip this one because it's very similar to what we just did. I do want us to look at one of these proofs, but let me look. I'll tell you which one's probably the harder one. Okay, let's look at the last one. Let's look at this one, okay? We are given this information. We want to prove L parallel to M. So let's see if we can get through this proof. So where do we start? Given. I'm going to try to write on the board, but we'll see. So statements, reasons. You can split up your given and write them separately, or you can write them all at once. I'm going to have angle 1 is congruent to angle 4. That is given. Then I want you to go to the picture and mark that. Angle 1 is congruent to angle 4. Right now, stop what you're doing and ask yourself, what does that tell me if angle 1 is congruent to angle 4? Okay? Should tell us that these two lines are parallel because these are what kind of angles? Okay, so I'm going to write that. I don't know if we need that in our proof, but I'm going to write it and then we'll go back and change it if we don't. So L is parallel to N. What does my reason have to start with? Converse. Converse of, and I'm going to abbreviate, but don't abbreviate on your homework, alternate interior angles theorem. Okay? Now we're going to write down our rest of our given. So number 3, we have angle 3 and angle 4 are supplementary. Again, I'm abbreviating. Don't abbreviate on your homework. Look at 3 and 4. What do we know about 3 and 4? Okay, they are same side interior, and if they told me they were supplementary, what does that tell me? Okay, which lines would be parallel? M and N. So number 4, we could say M is parallel to N. Hold on just a second. Hold on just a second. I forgot to write this one down. What was number 3? Given. Number 4, what's my reason? Converse of same side interior angles theorem. Please don't get in a bad habit where you think you can abbreviate on the homework. I'm going to say that over and over again. Okay. Now, we have not learned a quick theorem that would take us from here. Oh, yeah, I don't know. Hey, they are or I am a seal. One of the two. Are. We have not learned a quick theorem, which is what somebody was leading to back here. We think of the transitive property, but transitive property is only for equations or congruent statements. So we're going to learn a theorem, but we haven't learned it yet. That will make this super quick. Since we haven't learned it yet, we're going to have to do something first. If we want L and M to be parallel, what do we need to be true about angles 1 and 2? Okay, so we need to show that 1 and 2 are supplementary. Right now, we have 3 and 4 are supplementary. Okay, so 2 and 3 are vertical angles, which makes them congruent. And if 3 and 4 are supplementary, then 2 and 4 would be supplementary, right? Okay. Substitution works for equations, but we don't have any equations written yet. So we can, but we're going to have some steps to get there. So if you told me 2 and 3 were vertical, and we know 3 and 4 are supplementary, and 2 and 3 are the same, then 2 and 4 would have to be supplementary, right? Okay, but we're not there yet, so we need to write that down. So number 5, first thing we said was angle 2 was congruent to angle 3. And what did we use to get that? Vertical angle theorem. And then number 6, we said, let's think about what we have here. We have 3 and 4 are supplementary. We have 2 and 3 are congruent. We're trying to say that 2 and 4 are supplementary. How is that going to lead us to 1 and 2 are supplementary? Okay, so 1 and 4 are congruent, and now we have 2 and 3 are congruent. We've got several steps we're going to have to go here. Yeah, it's transitive property of equality or transitive property of congruence. Okay, I'm going to stop because we're not going to have time to finish this proof. Here's what we're going to do. We skipped several. There's one I still need to show you how to do that wasn't on your notes. So I'm going to go ahead and give you your homework. Can you do all of 3-2? Yes. Can you do 3-3 that are proofs where you have corresponding alternate interior or alternate exterior like the first ones we looked at? If you get to some like this, you may want to wait because there's some things we haven't talked about. If you get to some that are about same side angles, we didn't work an example like that trying to show that they're supplementary. You may want to wait on those till I show you another example. So I'm not going to make your homework due on